Daniel. I'm a freshman, and I'm in the computer science department.
Tell us about your project today.
Yeah, so it's called Bouncing Balls. So I made a simulation of a world in which you can insert 3 different colored balls into the frame, and it will bounce off the edges, and it will bounce off each other as well. And depending on like what kind of collisions occur, like with the wall or with each other, it plays like different sound samples. Yeah, so you can click these buttons to add new balls, and then it will make different sounds depending on the collisions that happen here. And then these toggles change the speed of the new ball that you create. Yeah, so like when the balls hit the edge, depending on the color, it triggers like a collision event that triggers a sound sample to be played. And when 2 balls hit each other, depending on the color combination, it also triggers a different kind of sound. So I think it creates some interesting situations. Say if you like only added blue balls, or if you only added like blue and yellow balls, you would only hear like half of the samples. So it would be like completely different feeling, as opposed to like adding all 3 of them. And it also gets really chaotic if you add like a lot of balls.
So tell us about why you decided to do a project like this.
I just thought it was really cool. Like I just like the idea of having like a simulation control kind of sounds to play. So it's kind of random, but it's also like kind of guided randomness because you can influence how it works. Like there's a set pattern, but when you hear it, it still sounds kind of random. So I thought that was like a really cool contrast to have.
Tell us how you got it to work.
Yeah. So then I think the hardest part was getting like 2 programs to communicate. So I used Java to write the ball simulation, and I used Max to write the sound generation. So the hardest part was just getting the 2 programs to communicate with each other. So I made the bouncing ball like simulation in Java and got to send things to the other program to make the sounds. And then I had an interface in the other program in which you can add new balls and send information back to Java to tell the program to add the new ball to the simulation.
So is there a practical application, or is this like a video game just to have fun?
It's kind of cool. Like I saw some like kids playing it. They thought it was really interesting. You just like can add a bunch of things into it. It's a kind of like a game that creates kind of a sound. So I thought like it's just a really cool thing too.
My name's Ava Chen. I'm a senior in the CS department, and basically we're part of the House of Sound event that's going on today with Co/Music 314 and 316.
And I'm Albert Lee. I'm also a senior in the Coast department. And so what we worked on is we have a poem recitation from 5 different voices, and our entire piece is based off of sounds from those 5 voices, both in terms of melodic material and the rhythmic and percussion material.
Yeah, so the inspiration behind this piece was basically to mess with a bunch of different sampling. Basically, it's called in/fidelity. It kind of looks into the spectrum between fidelity and infidelity toward music, poetry, vocals, performance, the human spirit, all of these things. So we start off with these 5 voices, and they're all recording a recitation of this poem, which is basically created with borrowed language from other pieces of music. So this is kind of like a received language poem. And these are all recording voices. We use those 5 tracks for all of the percussions, as well as all of the actual musical material. Basically, it starts off kind of all these voices speaking, and then they slowly become dehumanized and distorted as the sounds kind of work to destroy the original source tracks. So I'm in the Glee Club, which is basically a singing group on campus. And so what I did was find 4 voices and like 1 voice in each voice part who I thought kind of quintessentialized that voice part. So we have a very deep bass, we have a tenor, we have an alto, and we have a soprano kind of voice. And they basically pan throughout our little space here. So yeah, it's my voice and 4 other friends.
I'm Matthew Wong, in class of 2019. So my project takes live video input, it reduces it down, and then it uses the RGB color values of the different pixels to decide different things about the music, from the next chord that gets played, the timbre, the rhythm, tempo, different things like that. yeah, it's pretty simple in concept, but I think it came out very well.
What made you want to do something like this?
That's a good question. Not quite sure why I decided I wanted to do something with video, but it just seemed like a fun idea. And it's something I kind of wanted to focus on the music more than the programming part, and it's something I felt like that gave me the ability to do that.
Did you learn anything new, or was there something exciting that you learned that you didn't know about?
Well, yeah, absolutely. I think, just the level of programming that actually ended up being involved, even though it's something I wasn't necessarily looking to do. Just like logic, especially in this language, is kind of difficult, and with this project, I feel like I learned a lot about doing that.
Yourself?
Yeah, I'm Layla Adu, and I'm an assistant instructor for Computer Music 314. And that's like a computer music, and it's crossed with a computer science, so both those students can take the course. And today is the House of Sound. It's a really special day because it's an end-of-year project, but it's also a celebration of how amazing these students are. So I've been really impressed by all the projects. Of course, I've seen what they've been doing throughout the year, but this is really their chance to shine and think of something inventive and totally new, where it's not an assigned project where they have to actually use this interface or this controller. You can see all the variations. So they've chosen their own controllers and basically their own concepts. So some of them are similar to each other, and some of them are totally different from each other. So I'm really excited about them as musicians now. Yeah.
So how does
I think it's really important for Princeton to have classes like this available, because I think that the students to be able to use their imagination. So sure, I think a lot of the students in this class are computer science rather than music students, but you can see how creative their musical brains are. And so it's just like, I guess, bringing out this lateral parts of their brain while using the discipline of music, but also thinking about the creativity of music. So I think that's a special thing about music, and that you need discipline and some kind of structure to the piece, or it's just totally chaotic. But then there's also this sort of total freedom and creativity where you can just dream up an idea, and these kids are brainy enough to get the resources and make it happen through the class.
Hi, I'm Erica Wu. I'm a sophomore taking Jeff's class, and I'm a computer science major. Right, so I was inspired by the Pixar movie Inside Out, and I wanted to see if I could map emotions in written text to music. So the way it works is that someone types in something, and then my program analyzes it, maps it to fear, joy, sadness, or anger, and then randomly generates music to reflect those emotions. So right now I'm going to type in a sentence. I was angry until I came to the House of Sounds. And it's going to analyze that text. So it's saying it starts off angry, and then it translates, and then it goes to joy.
Has it been working well so far?
So tracking emotions in written text is actually still a research problem, and I didn't know that coming into it, and I had 2 weeks to try to figure something out, figure out a problem that hasn't been really solved yet. So it works on words that are linked to emotion. If you give it nouns, it doesn't know what to do with it. So someone would say like, I like dogs, and then it would return fear. And then we're just like, wait, no, that's not right. So it works sometimes. And then the melody generation works. But the natural language processing part is still a work in progress.
I'm Ben. I'm a senior in the electrical engineering department.
I'm Emily. I'm also a senior in the ELE department.
We're making a interactive chessboard. So as you play chess, it generates ambient music and also notes that go with it. So we have sensors in each of the squares in the middle 4 rows. Each square detects if a piece is on the square. When the player puts a piece on the square, some note would be played.
Yeah, so we have like kind of two different mechanisms. The first is a water drop sound that occasionally plays when you move the piece onto the square. And the second is just like a cycling pizzicato sound.
So my name's Jonathan. My project's called Acoustic Space, and it's a VR experience. So what you do is you wear these headphones and you look into here. It's a 360-degree video audio, so you can look around in your environment. It looks like you're in some fancy place in Europe. And there's these bubbles that kind of pulse to the beat of a song that you're listening to. And they're moving around you, and you can kind of turn your head and look at them. And basically what happens is the audio sounds like it's coming from the bubbles. So whenever you turn your head or they move past you, it changes kind of the direction the audio sounds like it's coming from. And it does that by changing the amount of volume coming in between the left and the right channels. And your brain kind of does this thing where, like, for example, if a sound is coming from like over here, you know it's coming from over here because the sound hits your left ear first and then your right ear by like a fraction of a second. So this kind of exploits that to fool you into having 3D audio as well as 3D video.
Hi, I'm Catherine Liu, 2017.
Hi, I'm Karen O'Young, also 2017.
And I'm Jeffrey Han.
Okay, our project is a soundscape, and as you can see, there are a bunch of different sounds that's going on, and we have two main sources of input. One is from the video feed, so then depending on movement or the number of people in the feed, there are changes to the sound or some sounds are made. And the other source is a microphone that people can input, I guess, their own recordings into it, and that will just loop. So one of the features of our system is motion detection, and the more motion there is, the more of this current certain sound is being made. And the idea is that because this is an interactive exhibit, that people might come and walk around and look at it, and so it'd be kind of cool if someone walks around more. We're kind of trying to take advantage of our audience.
Hi, I'm Carolyn. I'm a senior in the electrical engineering department.
So tell us about your project today.
So my project is the tiny accordion. I really like accordions, so I decided to I was inspired by that, and also I wanted to bring music to your fingertips, literally. So I thought it would be cute to make something very small and very simple, but yet fun, that you could just take around with you anywhere. So basically this is a tiny accordion. So this on here is an accelerometer, and based on your orientation, it will change the pitch and then also the high pass cutoff frequency. And then also, depending on your Z orientation, you can produce chords or not. And then this basically is mimicking how an accordion works. So the 4 sensors inside, and then the springs press against it. And so based on how fast you're changing the force, it'll change how loud the volume is. So the faster you change the force, then the louder it'll be. Sorry. So I really have to thank the electrical engineering department for teaching me all the things that I needed to build something like this. For example, the blocks that I had were 3D printed in the lab in the EE department. Rad, the lab manager, helped me a lot with that. So I learned a lot of the hardware knowledge from my electrical engineering classes, such as the 3D printed blocks, the sensor integration with the microcontroller. But the real missing link was the software component, which I learned from Jeff's class. His class really allowed me to bring this project to life.
I'm Andrew. I'm a junior in the computer science department. So I'm using Microsoft Connect and playing a sine wave whenever someone moves their hand within a depth threshold. So this means that people can reach into the sound sort of and change the frequency by moving their hand up and down. Yeah, and the user can also make the sound louder by stepping forward or backwards, and you can adjust the threshold. So if you want to get really close and just play with your fingers or your hands, then you can do that, or you can step back and play with your entire body. Since it's clustered in a certain way, since I cluster based on the number of pixels, when you're far back enough, you can use both hands as a single instrument. So it allows you to sort of have, like, pretend you're holding something in between your hands, like it's magic.
So is there a practical application for your project?
So this kind of Connect technology can be used in a museum or something similar because it makes no sounds when you're not standing right in front of it. So it's something that can always be on, and then a user can interact with it when they so desire, producing sound, or if you use it for a display, then it can, speak words about an exhibit that's nearby. Yeah.
So we just saw so many great projects from the students. What's going through your mind when you're watching them?
I'm just super proud. I'm really proud of how everybody got what they wanted to do done. So many students kind of had an ambitious project idea and they really pulled it off. Yeah, so I think it was just really fun to have some students coming from engineering background, some students coming from a more artsy background, but everybody was able to, meet in the middle, and the people who came from more engineering things really, we had these listening assignments over the course of the semester where they had to kind of learn to do critical listening and really to think about the artistic and aesthetic qualities of a piece of music, and then also had to learn how to technically accomplish something that they thought of in their mind. Like if you imagine some kind of sound, how would you make it electronically? Yeah, I think, well, if you think about it now, technology is connected to all music production that you're listening to. So when you listen to a pop song on the radio, every sound in that came out of a computer essentially, or was heavily edited and processed by a computer, even the voices. So it's kind of inescapable in a large way, but also there's just so much power and interesting things that you can do when you apply technology to music. And what we're trying to teach in this class, in both of these classes that this event showed the final projects of, is more about kind of like, it's called electronic music through composition, performance, and programming. And it's really about thinking about the musical aspect and thinking about how do you put that together. How do you actually build software in order to do things that you want to do that commercial applications wouldn't necessarily make possible because nobody's necessarily thought of it, or it's not a common need. So that's kind of, we were trying to get them to think of unusual creative applications for technology and music that, and then have them gather the skills in order to build those things from the ground up.